pretty darn quickly. You will need a calculator. All right. Oh, hey, we got more people. Good. All right. We're on page 513. Go to page 513. We're going to be starting. 513. All right. So Pythagorean theorem, stuff you've used before. You do need a calculator, so please get a calculator. Go put your phones away. And let's get started. So here we go. So the Pythagorean theorem relates to the lengths of the hypotenuse and the legs of a right triangle. We've definitely used Pythagorean theorem plenty of times over the course of what we've done. So I want to mention this thing here. Have I talked about Pythagorean triples before? Have I mentioned that before? Pythagorean triples? No? Okay. So we all know what the Pythagorean theorem is. If you have two legs of a right triangle, if you square those lengths, it equals the square of the length of the hypotenuse. And we've used it plenty of times. A Pythagorean triple, all that means is all three numbers in the Pythagorean theorem, A, B, and C, are all whole number values. That's all that means. So because most of the time when you use the Pythagorean theorem, we end up with like random decimals for a lot of things, right? So these Pythagorean triples are basically, if you notice them, it can make the work quicker. You do not have to memorize these, but if you do remember some of them, it just makes your life a bit easier. So if you have a right triangle where the legs are 3 and 4, the hypotenuse is going to be 5. And that's because 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. So same thing here, 5 squared is 25, 12 squared is 144, 13 squared is 169. So 25 plus 144 is 169, so 5, 12, 13. And it works with these ones as well. Plus, it also works for every multiple of each of those values. So these are, the top row are like the basic Pythagorean triples. This is each length doubled, 6, 8, 10, each length tripled, 9, 12, 15. So any multiple of 3, 4, and 5, as long as it's the, the same multiple, 30, 40, 50, that also works. So if you end up, recognizing those or multiples of those things, you can sometimes just skip using the Pythagorean theorem if you have some of them memorized. You're just like, oh, okay, I know that the third number is a whole number and I know what that number is going to be. If you don't memorize them, that's fine. But it can make your life a little bit easier if you do. So this is stuff that we've been doing for quite a while now. So I'm going to be very quick, at least with this first example and maybe even further. So the first problem here, what is, let's see, a squared, b squared, and c squared. Does it matter, real quick, does it matter which leg is A and which leg is B? You guys, listen up, here we go. Does it matter which leg is A and which leg is B? No, doesn't matter. Either one of these could be A or B. They could be switched, it doesn't matter. What does matter is that the length across from the right angle, the hypotenuse, is always going to be in the C position. So a squared plus b squared is c squared. 17 and 7, those are A and B. It doesn't matter which is which. It matters that x goes into the C location. So what is 17 squared? $289. All right. What is 7 squared? 49. All right. If you add those together, you get 338. If you square root 338, it ends up being 13 times the square root of 2. Now, this is the exact answer. But there's also a decimal approximation. If you want the decimal approximation, it'd be 13 times the square root of 2, which is about 18.4. So (13 times the square root of 2, or about 18.4. So this is exact, that's approximate. If it tells you to give an exact value, write it, including the square root if there's a square root in the answer. If it tells you to approximate it to whatever decimal it tells you to approximate to. Okay, you know how to do this. We've done this a lot already this year. So turn the page. This one says, use a Pythagorean triple to figure out the value of x. So if you look at your list on the previous page, do you see 50 anywhere on here? Right over here, right? 14, 48, 50. So what value is x? Here's 14, here's 50. What one's missing? 48. There you go. That's the answer. 48. Yeah. So Pythagorean triples on that previous page just mean if you have a right triangle where all three lengths of the right triangle are whole number values, that makes it a Pythagorean triple. And so if you have a leg of 14 and a hypotenuse of 50, and it says to use a Pythagorean triple, if you go back a page, here's a leg of 14, there's a hypotenuse of 50. So the other leg has to be 48. Yeah. Or if you want to, you can do the math. This is our value of C right here. So 50 times 50 is 2,500. 14 times 14 is 196. So subtract 196, and you get 2,304. Square root 2,304. What do you get? 48, which was the answer. Cool. All right. Do this one. Use the Pythagorean triple. Check the ones from the previous page. Find a leg of 48 and a leg of 20 and give me the hypotenuse value. Is it on there? No. Okay. So how could we figure this out then? These are going to be multiples of something. 48 and 20. By the way, these are the legs. So let's see. Are both 48 and 20 multiples of 3? Forty-eight is, 20 is not a multiple of 3 though. So it's not 3, 4, 5. 48 and 20 are both multiples of 5 and 12, right? What's that? Good call. So that doesn't work either. Okay, let's keep going. 8, 15, 17, 20 is not a multiple of that either. So this is getting interesting. So what do we think then? How does this work? So 20 is a multiple of 4, but what's that? Well, the smallest length would have to be a multiple of 3. And this one isn't a multiple. Well, actually, no. The smallest one would be a multiple of 3. The second smallest would have to be a multiple of 4. So if we think about it that way, is the smallest length here a multiple of 5? Yeah. Is the middle length a multiple as 12 is a multiple of 12? Yeah. So it's probably going to be 5, 12, 13. Okay. Because 20 is not a multiple of 8 or 7, so it is a 5, 12, 13. 5 times what is 20? 4. 12 times what is 48? Should be the same number. 4. So 13 times 4 is what? 52. Or if you want to, you can just use the Pythagorean theorem. 48 squared plus 20 squared equals c squared, then square root it and you get 52. So a couple ways of doing that. All right. Using the Pythagorean theorem. Like I said, it's going to be a quick lesson today. Example 3. So a summer camp. Good? Okay, listen in. Thank you. A summer camp is building a new zipline course. The designer of the course wants the last zipline to start at a platform 450 meters above the ground. Whoa, that's tall. 450 meters above the ground. That's like like 1,500-ish feet. That's real high. Must be into a canyon or something, because that's crazy. And 775 meters away from the base of the platform. How long? Yeah, right. That's crazy. How long must the zip line be to meet the designer's specification? So basically, we're just going with a vertical height and a horizontal height, and we need the diagonal height. So a squared plus b squared equals c squared. And it looks like we're calling the zip line length x. So we're going to get, by the way, this is going to be some real big numbers. We're going to get 450 squared plus 775 squared. Those are going to be very big numbers. What is 450 squared? 202,500. What about 775 squared? That'll be even bigger. 600,625 plus 600,625. All right, if you add those together, it just tells you that you're going to get 803,125. And then if you square root that, your calculator, your scientific calculator will probably give you this as your answer at first. And then does everybody remember how to get from this? This is called simplest radical form, by the way. Does anybody remember how to get from simplest radical form to decimal approximation? Yeah, just push the button above enter. So when you type this in, you'll probably get this. And if you have this, just push the button above enter, you'll get the approximation, which is about 896.17 meters. There you go. Try the one at the top of 515 on your own. And then, you know, maybe draw a little diagram of it as well, just over to the right side here. Give yourself some, little bit of a visual there.
The biggest number always has to be C, right?
Correct. What's that?
Is 12 the biggest number, is that?
No, X will be. It's because it's saying the base of it has to be 12 feet long. And the length across from the right angle is always going to be the longest side. And it says to find the exact length. That means leave the square root symbol in your answer. Leave the square root symbol in your final answer, yeah. So when it says exact length, that means if the answer has the square root, to leave the square root. So don't round it, basically. Better know what it is? What's that? It's definitely more than 5. Yeah, it's the square root of 145. Yeah. Which basically is, let's say 12.042 feet. We'll just 12.042 feet. That's not exact, but it's, you know, never a bad idea just to translate it, just so you have an understanding of what's going on. So it's barely the entire length of it. Well, okay. The entire diagonal length of the actual ramp is barely longer than the horizontal distance from the edge of the ramp to, I guess, the entrance of the school, that 1 foot up. So that's our answer. Square root of 145 is the exact length, which is roughly 12.042 feet. Okay. That's because 12 squared is 144, 1 squared is 1. So that's just 145, square root of that. All right, now what we got for the rest of the class today, listen up. You're gonna have to pay a little bit closer attention, because when we start talking about the converse of the Pythagorean theorem, some of this stuff will be new. There's not a whole lot left, not a lot of math left for us to do in the notes, so it's not going to take that long. You're going to have lots of work time today. But let's talk about the converse here. So the converse of the Pythagorean theorem also holds. That basically says that if you have a situation where you've got a triangle and the two shorter sides of the triangle squared equal the longest side of the triangle squared, that means that the triangle is a right triangle. So instead of starting with the right triangle and saying squares of the legs equal the square of the hypotenuse, this says the other way around. Okay. Hey guys, put the phones away. So here we go. I'm going to read that off here, and I've already explained it, but I'll just talk about this again. So the sum, if the sum of the squares of the lengths of the two shorter sides of a triangle is equal to the square of the longest length, then the triangle is a right triangle. That's what it's saying. So we're going to be testing the Pythagorean theorem to see what happens after this. You can also use side lengths to classify. Not only, so if it fails the Pythagorean theorem test, it means it's not a right triangle. But as long as the two shorter sides without squaring them add up to be more than the longest side, that means it still is a triangle, because we learned that a couple of units ago. And we can determine if it's a right triangle, an acute triangle, or an obtuse triangle based on the squares of the sides. So here we go. Theorem 9.6 says, if the square of the longest side, so if the longest side of a triangle squared is less than the sum of the squares of the two shorter sides, that makes the triangle acute. So it's like, if you have a right triangle where you've got your two legs, like here and here, and this side here, the square of this side here ends up being shorter than the square of the other two, that means this has to be brought in a little bit, which turns into an acute triangle. This angle here is less than 90. All three of them are less than 90. The opposite direction works as well. So here's a squared plus b squared equals c squared. Here is a squared plus b squared is greater than c squared, or c squared is less than a squared plus b squared. We go back to the right triangle and we make it open like this. If c squared is now greater than a squared plus b squared, that makes the triangle obtuse. So it all has to do with how that angle works. You can just kind of hinge it and kind of see how that works. So that's what this last one says. If the square of the longest side is more than the sum of the squares of the two shorter sides, then it's an obtuse triangle. You connect it here, that makes it obtuse. So that's what we're going to be dealing with the last page of notes. So go ahead and flip the page over. We're almost done. Super quick day, which is nice. It's always nice to start off a new unit with a simple-ish kind of a lesson. Now, I say simple-ish, but then all of a sudden we've got coordinates. Again, okay. Determine whether these points can be the vertices of a triangle, first of all. So that's where we have to determine, can it even be a triangle? And that means that the two shorter lengths have to add up to equal the longer length on its own in order to even be a triangle. And then we are going to determine if it's a acute, obtuse, or a right triangle. So if you want to figure out if it can even be a triangle, you first have to, you don't have to draw it on a graph if you don't want to. We're not going to here. You can if you want to. If you want to grab paper and see what it looks like, go for it. You're more than welcome to do that. And if we just did a little grid over here, let's see. I'm just going to do this real quick. I'm going to make a really sloppy grid right here. And let's see. I'm going to try to make these, I'm going to try to space these out about the same as the other lines here. So if I was just going to do something like this, these dotted lines are going to be the vertical grid lines, and the black solid ones will be the horizontal grid lines. So I'm just going to be making a mess of this upper corner here for a minute. Oh, absolutely you can. Yeah, if you'd rather have coordinate grid paper and see what it looks like that way, feel free. It'll look a lot nicer than what I'm doing. Or if you want to cut some out and like tape it up here, that's fine too. You can do what you want with that. I'm just going to do a really sloppy one here. I'm going to count by twos because I don't really have enough room to do everything I need to. So if I was to have A is at 2, 2. So I'm just going to say 2 here, 2 here. We'll just call that A, 2, 2. B is at 5, 7. So here's 2, 4, 5, and then 2, 4, 6, 7. That's right there. There's B. There's A, B, and then C is at 10, 6. So 2, 4, 6, 8, here's 10, and then 2, 4, 6 is about here. You don't have to. I'm just saying, if you wanted to make a graph of it, you could. You certainly don't have to make a graph of it if you don't want to. I'm just making a really sloppy looking graph here. Now, if you wanted just to kind of see what kind of what coordinates you have to compare in order to see if it's a triangle or not. Now, obviously they connect up here, but we still have to test the numbers down here to make sure it actually works. So you have to find the distance between A and B using the distance formula. You have to find the distance between B and C using the distance formula. You have to find the distance between A and C, once again, using the distance formula. So that work is already done for us. So the distance between A and B ends up being equal to the square root of 34, which is, let's see, approximately 5.83. So that's about 5.83. The distance between B and C is the square root of 26, which is approximately 5.1, right around 5.1. And then the distance between A and C is 4 times the square root of 5, which is approximately 8.94. So to determine whether or not we even have a triangle, the two shorter lengths, those two, because that one's clearly bigger, have to add up to equal more than that, which they definitely do. Right? Whole number here is 5, whole number here is 5, whole number here is 8. 5 and 5 is more than 8 for sure. We don't even have to worry about the decimals to know that this is a triangle. So yes, it is a triangle. Oh, it even tells us right here, 5.83, 5.1, 8.94. Okay. So once we have those values, then we are going to determine, let's see. Determine whether they can form a triangle. So yes, they do. So they do form a triangle. And by the way, you don't have to write it out using these 3 different inequalities. You know which side would be the longest side. The longest side would be 8.94. The 2 shorter sides have to be more than that. So yeah, it's going to be good. Okay, now we're going to use those 3 lengths, and we can use the approximations right down here. And we're going to throw that into the Pythagorean theorem. And we are going to figure out what kind of a triangle we're actually looking at. So the type of triangle that we are looking at, so if it's a right triangle, this is the most important part of it. If it's a right triangle, then the value of C has to be the longest side. So the 8.94, the longest side always takes the C position. So we're checking, does 8.94 equal, or 8.94 squared, does that equal 5.83 squared plus 5.10 squared? And the answer is no, it doesn't. 79.9 is 8.94 squared. The sum of 5.83 squared and 5.1 squared is right about 60. So that means that the hypotenuse, well, it's not even a hypotenuse because it's not a right triangle. The only way this is a right triangle if those are equal. And they're not equal, so it's not a right triangle. But it is a triangle. So that means it's either obtuse or acute, because those are the only 3 kinds of triangles based on angle. Right triangle, obtuse triangle, acute triangle. Because C squared is larger than A squared plus B squared, what kind of a triangle do we have? Look at the last page. If C squared is greater than A squared plus B squared, it's obtuse. Yeah. And actually, if you graphed it, you can probably see that the angle at B is a little bit more than 90 degrees. So that checks out with how it looks. Now, you can't just look at it and give an answer. You got to do the math. But that's our answer, is this triangle is obtuse. So I want you to do this last one on your own. I'm going to give you 5 minutes because it'll probably take a few minutes to do this. You have to determine, first of all, is it a triangle? If it's a triangle, what kind of triangle is it? So take a few minutes on that. If you want to use a grid and graph it out, you can, but you don't have to. All right, let's have a look here. So first of all, it is a triangle because The distance between J and K is equal to the square root of 20, which is about 4.47. The distance between K and L is equal to the square root of 5, which is about 2.24. And the distance between J and L is actually exactly 5. Everybody get those numbers? No? What's that? Didn't do the distance formula. If you did the distance formula, you would get those numbers. Okay. You get rough, and because those two smaller ones definitely add up to more than 5, that means it is a triangle. So once we know that it is a triangle, which it is, we then have to figure out what kind of triangle is it. So if it's a right triangle, C would be, I mean, I just writing ABC. C would be 5 because that's the longest one. A and B would be the two shorter ones. So if we square the two shorter lengths and add them together and compare it with 5 squared, we end up with a number that is almost exactly the same, but we have to consider that we rounded those. And so the question is, are they exactly the same, or are they just really, really close to being the same? Uh-huh. But, you ready for this? What if we just used the straight up square roots as the exact values? Exactly. So if the shortest length is equal to the square root of 5, which is about 2.24, if you take the square root of 5 and you square it, by the way, if you square any square root, and this is just kind of a thing, some of you might know this already. Listen up in the back, please. Thank you. Some of you might know this already. If you square a square root, the square and the square root undo each other. They're inverse operations, meaning the 2 and the square root, the square and the square root cancel each other out, and you're left with 5. Over here, same thing. The square and the square root cancel each other out, and you're left with 20. 5 squared is 25. What's 5 plus 20? 25. That's a right triangle. A squared plus B squared equals C squared. So if you end up with, here's kind of a little thing that you can think of. If you're using decimals and the decimal value ends up being super, super, super close, go back and double check squaring the square roots to see if it's exactly the same. Chances are it certainly could be. So this is a right triangle. Yes. And that's all I've got for your notes for today. So we got about 38 minutes.